environments, you will be submitting Jupyter Notebooks, and we ask you that these notebooks can be executed in Google Colab. So we selected the Google Colab environment so that everybody has the same platform, but more importantly, because as you will see, there are a lot of libraries that are needed when we're doing machine learning programming. So by using Google Colab, we make sure that you don't have to install anything on your computer if you don't want to mess around with these installations. So this tutorial is meant to be an introduction to Jupyter Notebooks and Google Colab. Many of you are probably familiar with these environments, so it's an optional tutorial, but maybe you will learn a few tricks along the way. So let's get started. So the idea here is to make sure that everybody can write and execute a Jupyter Notebook, that you can do so in the Google Colab environment. So for CSI 4106, we're expecting that you are fluent with Python. If you need a refresher, there's this excellent tutorial that you can find on the official website for Python. A good exercise could be that you create a Jupyter Notebook and you refresh your memory going through these instructions on the official Python website. If you need additional help or further your Python skills, you can also use these more advanced tutorials. All right, so let's get started with the idea of a Jupyter Notebook. So a Jupyter Notebook is a document that typically people like to share. And this document mixes together computer code, plain language, and some data, some visualization. So the result of the execution of the program produces charts, 3D models, graph, etc. And these are embedded into the document. It's allowing you to program interactively, to change the values of the variable and to re-execute the code in a very interactive manner, which is one of the reasons why people like to use Jupyter Notebooks. It's because it's a great environment for prototyping, for developing applications. As a bonus, it even allows you to write programs from your tablet, from your phone. So I find it very convenient. A lot of people are actually switching to Jupyter Notebook once they discover how easy it is to use. Okay, so here is a link to a document that I prepared. It's currently stored in my GitHub, and by clicking on this button, it will bring us to the Colab environment and launch this notebook that I created. So as you can see, it's pretty straightforward. I'm in a browser. This is a web page. And what you see here is an example of a Jupyter Notebook. Let's just scroll the page to see what it's about. So as you can see, as all the web pages, there's a lot of text. And then if I scroll down, you see that the text is intertwined with some programming cells. Some more programming cells here. Some text, and then eventually some graphics. So here the graph that you can see on the screen has been produced by the code that is above the graph. So I could try to run this program. So anybody can view a notebook on Google Colab. But if you try to execute the cells of the notebook, obviously you need to have an account. Why do I say obviously? Because you're now borrowing the CPUs of Google, so they want to keep track of how much resources you're using, and if you're exceeding the amount that comes with a free account, then you have to pay to get the next tier. Okay, so let's sign in. Okay, so I'm now signed in. I can clear the output. So what do I mean by that? So previously I showed you that there was a graph, and the graph had been produced by the execution of this cell. But now this graph has disappeared, and anything else that would have been printed by those cells has disappeared. So we have the fresh notebook with the cells that have not yet been executed. So here I'm going to use a number of libraries, pandas, matplotlib, etc. For today we don't need to care about that. We'll have time to dig deeper into those concepts. What we would like to do today is simply understand what is a Jupyter Notebook, how we can modify a Jupyter Notebook, how we can execute cells, so on and so forth. Okay, so it's a very basic environment where for us there are two main types of cells of interest. There are the code cells where you're going to be writing your code, and there's the markdown cells. So currently this text that you see is a markdown cell. If I double click on the cell, I now see how it was created. So this markdown format is very simple. Sections are introduced with this hash sign. If I want to introduce a subsection, I'm going to use two of those, and a subsection, you will have guessed, I would use three of those symbols. If I want to create a list, I have these hyphen in front of the text. If I want to put something in bold, I simply wrap around the text with these double stars. But you don't even need to be too preoccupied with this, because the editor allows you even to format the code for you. So it's a very simple way of programming and updating these cells. So if I make some change, so making some change, then when I'm exiting this editor, you see that the bold that I created is still there, the change that I made is still there, so you can edit the cells like this. And eventually you would want to save back the result to either your Google Drive or a local drive, because you're now in the Google Colab environment, so all of this is running on a computer from Google. Okay, so that was a text cell, and here is a code cell. So for this example, for the first example, we're going to use data that is provided by the City of Ottawa. The City of Ottawa is providing a lot of data through their open data portal, and the data that I'm using is this data about the temperature of the various of the Ottawa River. So we're going to use that. And it's not particularly important, the example that we're using. As I said, we don't care really about the code. We just want to understand how we can create those notebooks and execute them. So if you want to execute a cell, there's many ways to do this. One of them would be to do a run all. it would execute sequentially all of the cells of this notebook. But typically that's not what you're doing, because as I said, these Jupyter notebooks are meant to be a very interactive environment. So typically what you do is you go cell by cell and you execute a cell, you see the output. If there's a bug, you fix it, and so on and so forth. You move from one cell to another. So here I can execute this. So here there's a warning because this is code that was not created by Google, so they want to make sure that you know what you're doing. So someone could have sent you a link for a notebook that would require a lot of resources, so you want to know about that before you execute this. So here, this is my own code, so I'm going to go ahead and execute the cell. Here you see there's a sort of green check mark. It means execution was successful because it was so small amount of code. It ran almost instantaneously. Another important concept, and as I said before, all of this is currently running on a Google computer, so anything that you are creating will disappear at the end of this session. So if you did create some important data as you were executing your notebook, you want to make sure that you will save a copy of that to your local machine. Okay, so here, this is the URL where the data is found, and we're going to fetch this information. That was pretty quick. Now it was an Excel file. I'm going to read the content of that Excel file because it's a bit large. You're going to see that it takes quite a bit of time to read that information. Previously, I had a good look at the file. I know that there was a sheet that was named Britannia raw water temperature, so that's the one that I'm loading. I did look at the content of the file, so I know that the information that I'm looking for is located in the columns B to U and between the rows 11 to 375. Okay, so as you can see, it took 33 seconds to read that information. So here I have some code that says that the years that I'm interested in right now are 2005 to 2023. So let's execute this. And then finally, I'm using matplotlib in order to plot the result. So if I maybe look here, so you see that below the cell there's nothing, and then if I click execute, the result of the execution of that particular cell is displayed underneath. And if I were to save this Jupyter notebook, it's going to save the image within the Jupyter notebook. We'll talk about that later. So, as I said, it's meant to be a very interactive environment. So maybe I felt that the graph was too busy. So I can say I'm going to focus on years 2020 to 2023. So I'm going to execute this cell. So this has not changed the graph. In order to change the graph, I now need to execute the next cell. So what's going on here? So in the background, this Jupyter notebook is running in a Jupyter server. Actually, what has happened here is that Google has launched a virtual server. So it's a Linux machine that is running in the background. The Jupyter server is running, and it has launched a process that is executing Python. So all of the cells are executed in the same process, in the same Python environment. If I now want to update the graph, I need to execute the next cell. As you can see, the graph is now less busy because I have fewer years, and in particular we could see that 2023 the water temperature was actually lower than the previous years. So maybe one more note about the order of execution. So as with any program, the order is very important. So if I'm to use one of those libraries that you can see here, well, I need to load those libraries before. And so when you start using Jupyter Notebooks, one of the maybe main issue that you may encounter is that you forgot to execute a cell that was defining some of the variables you're using or loading a library that was important. So it's important that you understand that you have to execute the cells in the right order, for the right output to be produced. All right, so let's go back now to our main presentation. So you might want as well to execute these Jupyter Notebook from your local computer. Okay, so you don't have to. It's expected that you can do all of your assignments using Google Colab, but some of you may want to execute the notebooks locally for whatever reason. Okay, so I'm just going to escape the full screen mode. I'm going to go to a terminal. I'm on my local computer. As you can see, I've already downloaded copies of all the Jupyter Notebooks that I'm going to go through during this tutorial. You can see that these are files with extension IPyNB, so py as Python and NB as notebook. And if I want to execute the very same notebook, I gave you here the command. As you can see, there's a little icon that has appeared, copy to clipboard. It's always the best way to do a cut and paste. This removes any HTML formatting. So if we go here, I can paste the command. And as you can see, it has accessed my browser, launched a server with the content of the notebook that we would like to edit. Let's go back to the shell. Okay, so here you see the command that I used was Jupyter Notebook and then the name of the Jupyter Notebook that I'm interested in. If we scroll down, you see that it locally started a Jupyter server. It's telling me that it's running on my local host with this particular port, and it has automatically used the default browser to give me a starting point where I can edit the notebook. So it has the very same look and feel as if I was using Google Colab. So it's a web page, has all the text cells, has all the programming cells, but now I'm on my local machine. So if I'm executing something, it's executed on the CPU of my computer here. Okay, so just like before, we can execute the cells, we can change the cells, we can create new cells. So here I can create a cell right here. I can change the nature of this cell. Here it's a code cell. If I want to add a text cell, I just change the type to markdown. Okay, so here code or markdown. Here is a markdown cell with bold text. Okay. And to execute a markdown cell simply means rendering the cell in HTML. We can add one more cell. You see here it's a code cell because now the kernel is a Python kernel. I can say a equals 4, execute that. Oh, it was executed actually. We can print the value of a, it works. In fact, when you execute a cell, the output is whatever was the last statement. So here it simply displayed the content of the value of the variable a. Okay, and I can go on and execute all of these cells and eventually get all the very same results that I got from the Google Colab, but everything is running on my local computer. If we go to the File menu, you will see that it has this entry that initially may look a bit bizarre. It says shut down. What is it shutting down? Well, it's shutting down the server that is running this notebook. So if I do the shutdown and I go back to my terminal, you see that I now have the hand. I can type more commands if I want to. The server has shut down. Let's go back to our presentation. Okay, so why do we like to use Jupyter Notebooks? Well, it's a very intuitive environment for developing interactively programs. Because it's running in the cloud, if you're using Google Colab, as I said before, you can even use your iPad, your favorite tablet, or your phone for making a last-minute modification on your assignment, or if you have an idea that you would like to test and you're on the bus, you can have a Google Colab file that's available for you, and you just put in some commands and you're programming like that on your phone. It's really great for visualizing because you have in the same document the code, the text that goes with the code, and you have the output. So if you're creating any graph, you can see the graph. And these Jupyter Notebooks became very popular in the scientific community because we would like our results to be easy to reproduce. So by providing a Jupyter Notebook of our code, people can execute the code that was provided in the publications. So how can you work with these Jupyter Notebooks? There's many ways. The easiest way is to use Google Colab. The free version of Google Colab should be enough for you to execute and develop all the necessary code for your assignments. If you have personal projects and you end up using too much CPU time, you can pay a very reasonable price and get access to more time. This also gives you access to more powerful GPUs, and it allows you to run in the background your Google Colab. So you can actually leave this web page, and the code will be running in the background. Another way to or develop your Jupyter Notebooks is locally, and we've seen an example. So it's allowing you to develop programming in your browser using the Jupyter server. You can also install an extension for Visual Studio, and this is also a very productive environment for writing your Jupyter Notebooks. And there are even things like Jupyter Hub that allow many users to collaborate on a one document. Let me just show you as well another benefit of using the Colab environment. I said before that programming machine learning application requires a lot of libraries. So on my local computer, I'm using something called Conda to manage the various libraries that I'm installing. So you see that for this particular class, I'm using the AI environment, and for the other projects that I'm working on, I have all these other environments. If we look at the libraries that are installed in the AI environment that I'm using for this course, so Conda list, you see a very long list of libraries. In fact, I have 267 libraries installed just for this course. So by using the Google Colab environment, you don't have to install these things on your local environment, which requires disk space, but also can become very messy. So how do you go about if you would like to install Jupyter on your machine? The preferred way, the easiest way, is to use pip. At some point in your developer's life, you will want to graduate to more complex environment like the pipenv or Conda Mamba, or what I'm using is actually called micro Mamba. At the end of this video, I'll talk about that briefly, but for now we're going to stick with the most basic way of installing Jupyter on your machine. So this is using pip. So first you want to make sure you have a recent version of Python and you have a recent version of pip. These are the commands if you're a Windows user, and these are the commands if you're a user of a Unix-like environment. It's fairly simple. You simply say pip install. Here I'm suggesting to you to install Jupyter Lab instead of Jupyter Notebook. This is because the lab environment is the most recent, and it actually allows you to edit many notebooks simultaneously. Once this is installed on your computer, you simply say Jupyter Lab, and it's going to launch the environment pretty much the same way that we had on the screen just a few minutes before. So with this tutorial, I'm providing you a number of examples for you to play with. And we're going to jump right away to example 3, which is an example where I'm showing what would happen if something was not installed on the Google Colab. Okay, so first of all, for all of your assignments, you don't need to worry. All the libraries that we will be using are pre-installed in the Google Colab environment. And in fact, for your assignments, you cannot install additional libraries, because that would mean that the TAs who are grading your work would have to install those libraries, which would be requiring too much time, could create problems such as clashes between various libraries, so on and so forth. So do not install additional libraries, but I'm assuming that you will like Jupyter Notebooks so much and the Colab environment so much that for your own project, maybe you will want to use libraries that are not already available in the Colab environment. But as you will see as well, it's going to give me an opportunity to show you a few more tricks. Okay, so here we see that we are in the Google Colab environment. We have access to the third example. Like before, this is an example with some text and some code. And here on purpose, I decided to make use of a library, the LangDetect, that is not pre-installed in the Google environment. I did so because I wanted you to have an example of what would happen if you try to use a library that has not been installed, and I want to show you the way around that, but also I want to give you a few more tricks. So here the expectation is that if I execute this cell because the library is not available, it's going to fail. So here we have our usual warning. This is not code that was developed by Google, so let's run it anyway. And as predicted, we get this error, module not found, and this is because LangDetect is not one of the libraries that has been installed. I'm proposing you a workaround. I'm going to copy, I'm going to copy this text. I'm going to go above. And just before, I'm going to do this. So here, this is an escape command. It goes to the shell that is behind the execution of this Jupyter server, and it will install the library. Once the library has been installed, now we can successfully load the library. You see now that the execution is complete, because we have the green check. It's been 12 seconds for installing this. Because the library has been installed, if I execute this, you see that it detected that the language for this string is French, so I can use it. So let's play a little bit. So let's add a new code cell. So I told you that this bang is an escape to a shell. If it's true, I should be able to run shell commands. So here I told you that my expectation is that there's a Linux virtual machine running in the background. If it's the case, I should be able to use uname to see the result is true. I can even say uname -a. It's going to tell me the exact flavor of this machine. If it's a shell, I should be able to list the file. We see that there's already a folder called sample. Maybe I'm curious, I want to look at that. Oh, it contains already all of these things, and it has a file called readme.md. So maybe I'm so curious, I want a cat, so I want to visualize the content of that file. If I execute this, it says, oh, we have included in this virtual machine some sample files so that you can play with that. Where are we actually? So I can print the working directory. I'm in /content. If I'm super curious, I can look at the root of the file system. I can look look at /proc to see what's going on this machine, so on and so forth. Okay, so there should be a CPU info, so I can look at that, catenate CPU info, so on and so forth. Okay, so this was just to give you a basic understanding of the Colab environment. So there is a Linux machine that has been started for you. It's executing the Jupyter server in the background, and if you would like to escape to the shell, you can do so. Let's go back to our presentation. Okay, so here I've created a simple example, stock price. Maybe this time we can execute it on my local computer. So if I start Jupyter Lab, you see the environment is slightly different than Jupyter Notebook. This is because now it's providing me a way to access the content of my disk, so I can actually load any of these documents that I'm interested in. So here was a small example that I created where I wanted to visualize the stock price for Intel versus NVIDIA for recent time. The idea being that NVIDIA has been very popular and successful because of machine learning, and I'm expecting that this will be reflected in their stock price. So I'm importing a library that allows me to pull stock information. I'm interested in the NVIDIA and Intel prices. This is the period of time that I'm interested in. I now remember that there's a bug that I need to fix. It's this. Okay, so let's execute our various cells. Oh, so YP Finance is not installed on my computer. So let's do that right away. So activate AI conda install YP Finance. That's an interesting case. Okay, so now it needs to install a bunch of other libraries, so it will turn out that I'm going to have more than 267 libraries installed for this course. Let's try this again. So now the execution was successful. Moving here, execution was successful. I was able to download the data. These are the columns of the matrix that I'm interested in. And now I'm plotting the information. NVIDIA is the blue line and Intel is the orange line. And as you can see, the stock price for NVIDIA was quite low. And then in recent year, it's skyrocketed. And now it's pretty much at the same place where the Intel stock price is found. This particular example, let's launch it in the Colab. Maybe it's going to be quicker. This particular example, I just wanted you to see that you may actually use Jupyter Notebook for your own notes. whenever I'm doing something related to math, I like to write some program to do some visualization and play with these things. Let's execute everything here. So I'm writing my notes about the concept. And here I was interested in the concept of the central limit, and I wanted to generate data from various distributions. So here it's a uniform distribution. Then I did some samples, and I'm plotting the histogram. And as you can see, the mean of all these samples has pretty much a Gaussian distribution. Then I wanted to experiment with an exponential probability distribution. So I use again NumPy and the Python matplotlib for printing the information. So you see that the data now is distributed as an exponential probability distribution. I'm doing the same kind of experiment. I'm doing 1,000 samples. Each one of them is of size 31. And then when I'm plotting the mean is pretty much distributed as a Gaussian, so normally distributed. Okay, so you may find it helpful for your own notes to use these Jupyter notebooks. And that brings us to our lecture notes. In the lecture notes, everything I'm writing produces a Jupyter notebook. And so here I was interested in a particular math function called a sigmoid function, so which I'm defining here. I'm creating some data and I'm creating the image of that data, and I'm plotting the information. The information is showed on the next screen. This is what the sigmoid looks like. So this graph was actually produced when I compiled my notes by the execution of this program. And why am I mentioning this? Let's first stop our things here. So I'm going to close this particular window. This one is a Colab. I'm going to close that window. This is also Colab. Leave. Stock price was on the local machine. I'm going to shut down this server. Shut down. Now it has been shut down. I can go back and I have the hand. So here I have a copy of the slides as a Jupyter notebook. So Jupyter Lab slides. So this is exactly what we've been looking at since the start of this video. The slides are available in a Jupyter notebook. I do think that it's amazingly helpful to have the slides as a Jupyter notebook. And the reason is this: if you would like to add some of your own notes to mine, you can just edit the content of the slides. So I like Jupyter notebooks, and then I can just update this. So obviously in your very own notes you will write something more meaningful than just this thing here. But the example was to show you that you now have the code. The code produced this. If I now clear the cells, I have to remember where it is. I believe it's here. Clear all outputs. Okay, so Now the graph is gone. If I click here, I can execute the cell and the output has changed. If I want to play with that, change the color, execute the cell again. So you see that it's very interactive. So all of the lecture notes during the semester will be available as HTML, React.js slides, but also as Jupyter Notebook. So whenever there's a machine learning example and you would like to make sure you understand the content very well, you can actually change the examples, make it your own and play with them. And that's pretty much what I wanted to talk about regarding Jupyter Notebook and Google Colab. So we've introduced the tools, we've introduced the notebooks and Colab, and as hopefully you've seen, this is very straightforward environment. Hopefully you will find it useful and easy to use. But I'm going to continue a little bit with this video and present you a few more ideas. So there's sort of bonus ideas. Okay, so these are just links that you can find in the notes where you can read about Jupyter, you can read about the Colab, and there's a primer. Version control. So by default, when you're producing these Jupyter notebooks, they will store the content of any media objects or the graphs, the figures that you've produced will be saved within your Jupyter notebook. Now, there's something particular about these notebooks. So here I will just stop the server. These are the files that we have. So what is a Jupyter notebook actually? What file format is it? So let's look at the file. It's actually a JSON file where you have cells. Cells can be markdown cells or they can be code cells. Markdown. And then some cells will be data cells, and these data cells will contain the images. And here the image for the stock price graph has been saved as a PNG image encoded in base 64 so that it can be easily manipulated. It's not a binary file. So what does this mean? Well, it means a couple of things. So it's a JSON file that contains images that have been base 64 encoded, so they can be pretty large. So it means that these Jupyter notebooks can be pretty large in size. So that's number one thing. Number two is that if you were to use a basic tool that you're using to compare your Python program, so a diff where you want to compare the difference between two versions of your code, what has been stored in the Jupyter notebook is a JSON file. So whenever you do the diff, it's going to be pretty hard to understand what's going on. So that's a bit of an issue. So there's many ways around for that. So first, for the size problem, when you are in your Jupyter Lab environment, you can say clear all, and you clear all outputs, and you can save the file. That would be one way. Very important. We're asking you not to do that for your assignments. This is because we would like the TAs to be able to grade your assignments and only execute the content if they see a problem. There are tools that you can install. One of them is NBConvert, that actually allows you to strip all the images just on the command line. And then finally, there are tools like Notebook Difference that allows you to do a diff of Jupyter Notebooks, producing a result that is closer to what you would expect, meaning the actual Python program behind the notebook. Okay, so that was it for the version control, file size issue of those Jupyter Notebooks. The next item that I want to talk about, and that's going to be the last one, is environment management. So first of all, I'm going to insist that it's probably not a good idea to attempt starting using a new tool during the semester. You really don't want to mess around with your local computer so that you're no longer able to complete your assignments. So I urge you to wait until Christmas. This is a fun Christmas project to do if you want to explore these other ways of configuring your machine. So please keep that in mind. So the easiest is really to use a Google Colab for this course. This way you don't have anything to install. The next easiest way to do your coursework is to use pip. The challenge with that is that it installs everything in a global environment. So sometimes you can end up with situations where a library you're using from one class is clashing with a library from another class. And suddenly, if it's just a few hours before a deadline, that can be pretty nerve-wracking. So I really believe that if you are to make a career writing code for doing machine learning, you should learn something about package management. So these are tools that are meant to help you manage your projects independently. I've already showed you before on my machine. If we go back to shell, conda, environment list, you see that I have all of these environments. And when I want to work on a different project, I simply activate that particular environment and conda list work count minus L, and that particular environment happens to have a different number of libraries installed. So here 416. So it allows you to manage your different projects independently and not to mess around with your various environments. So I think to know of a package management environment is really something helpful for project development. So there's an easy entry point, which is Anaconda. Anaconda is an environment that comes with a lot of Python libraries that are useful for machine learning pre-installed. Some people don't like to use this big environment because it's downloading a lot of libraries they don't need. It's using a lot of disk space, but it's certainly an easy entry point for starting to use the Conda platform. There's a easier or a more streamlined environment called Miniconda that allows you to install just the packages that you're interested in. So that's also an option. But Conda, I found throughout the years, sometimes has let me down. Whenever there are problems and with the packages that have been installed in the based environment, suddenly you can end up in situations where there are conflicts that are very, very difficult to resolve. So although I was using the conda commands, turns out that what I'm really using is a tool called Micromamba, which is a different environment that is statically linked, that does not have a based environment, that runs faster, that has fewer chances of leading to conflicts. Okay, so Micromamba is what I'm using right now. Very happy with that. But you can go at your own pace. You can start small using the Anaconda and move your way to more complex environment as you become familiar with all of these things. And as a last resource, I would like to point out this excellent resource from MIT, which is called The Missing Semester in Your CS Education. And this is something that graduate students learn the hard way. It's this idea that often, and especially if you were not in the co-op program, when you finish your education, there are so many things that you have to learn about Unix, about the environment, the package management, all of these things which actually would have been very useful to learn at the very beginning of your studies. So here the missing semester in your CS education is a series of lectures that will talk about the shell, the various editors, the command line, the version control, and all of these things. So if you have time, again, maybe a Christmas project, you might be interested in looking at those resources. All right, so I hope that this video was helpful and that you're going to be able to successfully complete your assignments. And if you have questions, remember that your TA and myself, we have office hours each week.